In this video, we're going to enter and debug a simple program into the MicroMaster. The example we're going to do is from one of the first labs for programming. This is a very simple program that adds two 8-bit numbers and generates a result that we'll then be able to see by going back into the monitor. Each instruction has a hexadecimal address, and it has information that's going to get entered in at those addresses. Because it's easy for us as humans to think of this in mnemonic code, you'll see the source code, and then finally probably the most important piece is the comments. The comments tell us how we understand it, and later on down the line, they also tell others how to understand our code. So let's get started. And again, you can find this output in the laboratory example. So we fire up the MicroMaster and you can see that the familiar ready prompt for the monitor is appearing. Something you need to remember about the MicroMaster is that the memory is volatile. This means that if the power is removed from the system, anything you've entered into the RAM is lost. So be careful when you're entering programs not to bump the power or to do things around your lab station. Okay, so let's enter this guy in. First of all, to edit memory, we use the DA function, which is the DA key. And the system comes up and gives us the first byte of the memory address. Notice that there's decimal points lit up. That tells us that we're working with a memory address and not data in the memory. By default, when we turn the system on, it's going to show memory location 8000. So you can see 80 is correct. So we press DA again. And the second part of that is correct. So we press DA again. And now it's showing us the information at memory location 8000. Well, we need to enter what the correct data is. And from our listing, we know that that location has 3E. And if you're watching closely, you can see that the monitor reminded us that now we're working with memory location 8001, and the next byte is entered 2, 3. So the monitor is friendly. It tells us what's going on at all times. In fact, if I wanted to go back and double check my work, I could use the back key, which is marked AH. And the monitor will gladly tell us, oh, memory location 8001, you put in a 2, 3. At memory location 8000, you put 3E. And I can also scroll forward. So there's my 2, 3. And now I'm at memory location 8002, and I can continue entering my program. So I need to enter the bytes 0, 6, 4, 2, and then at location 8004, we enter the opcode for adding, which is 80. And finally, at location 8005, we put in CF. CF is the hexadecimal code for restart 1, and that will cause control to go back to the monitor. So when you want to end your program and see what was going on inside it, you normally want to put a restart 1, which is opcode CF. So now that we've entered this, we can now run it. So we press the stop button right here because we're done editing the memory and we now want to run the program. To run the program, we press go. The monitor is confirming for us where we're going to make the CPU jump to. And that is, by default, memory location 8000. So there's the 80. We simply press one of the next buttons here. 00. And it's going to default that way on power on. However, once you run a program, the monitor is going to remember the last memory location the CPU was running at. So be careful. Don't just press the Go key blindly. So this all looks good. So we're going to press the Go key to make it run our program. And you can see it took a long time. You can see a B, which means break. That B meant that the monitor intercepted a restart 1, and it saved the information about the CPU registers. Now, to see what was going on, we actually need to inspect the registers. And we would do that by pressing R. And you can see the A register has 6.5. Well, how do we know that's right? Well, if you look at your source code, which we'll pop this back up here, you can see that the numbers we're adding were 2, 3, and 4, 2. And that certainly, when added together, is 6.5 in hexadecimal. So we do have a correct result in running this. So you've seen us entering a simple program, and you've seen us inspecting the results in the CPU register. Just again, to caution you, we're going to stop this command. We'll press stop. If we go to the Go command again, you'll see it says PC is 80. That looks okay. 06. Notice it's no longer at 8000. If you look at your listing, you'll see that the next memory location after the restart 1 was in fact 8006. So the monitor remembered that the next instruction to be executed would have been at 8006. Since we don't want to execute anything from there, we don't know what's there, we simply press stop, and there's no harm done at all. So good luck entering your programs. Take your time. Make sure to fill out a worksheet or have some kind of documentation that's printed in front of you when you're entering programs into the MicroMaster, and you'll have no trouble at all. Good luck.